Good afternoon. Thank you so much for giving me this opportunity to share the little that I have learned about R, what I'm still learning. In fact, as I'm preparing these things, even me, I'm learning, day by day. But it's a very wonderful experience. Today we're talking about R matrices and data frames. Does the word matrix mean anything to you? Or the word data frame? Do any of these two words mean anything to any of you? Have you ever heard of the word matrix before? M-A-T-R-I-X. Or the word data frame? If you haven't heard, just say you have not heard. Yes, it's a way of presenting data. That's very correct. It's a way of presenting data. I think the word matrix, I've not looked it up again, but if I remember from my residual knowledge, matrix has to do with like a net form. The way a net looks. And if you remember in biology, we used to have this in there that they call matrix. When you look at the cellular, the microscopic structure of plants, they call it matrix because the way they are arranged. If you remember something like that. So that's it. But in general language, even outside of data management, matrix, we're talking about tables and things like that. Like when you're drawing a table, maybe a work plan, for instance. When you're drawing up a work plan, you have a column that says objective, activity, expected outputs, those kind of things. Now, normally you will lay it out in a matrix. They call that thing, that table that you create is called a matrix. All right. So we're going to talk about matrices, about data frames. Then we'll do a brief overview of indexing and subsetting, and then some exercises. Now, recap. We're going to we talked about vectors. The last time we tried to define vectors. Can you just give me one takeaway you had about vectors? What's one thing that you understood about vectors? Just one takeaway that you had the last time that we met here. Any of you, please. In fact, all of you, just give me one thing that you learned, about vectors. No matter how small, no matter how big. What's the one thing that you picked up? Anything at all? Excuse me. I hope you won't say you didn't pick anything. No. That means I'm a horrible teacher. If you said you didn't pick anything, it means I'm a horrible teacher. Don't look into your phone. No. Just keep your phone. The answer is not in your phone. What was the one thing that you gained from that our lesson? About vectors. Okay, even about lists. What was the thing you gained, generally speaking? Yeah, your hand is up. Go on. What did you gain?
I gained that you can actually get a list of attributes or elements and put them together and store them in a particular variable.
Yes, exactly. So he said that. Sorry, to make it what?
Easier for manipulation.
Yes. So he said that he that what he learned was that you could form what do you call it? You could take a combination of different elements and make them into a variable and use it for various manipulations. Okay. What did you get? Yes.
Not need to take them on that time.
Exactly.
Have that maybe as
Yes.
something you can just apply to.
Yes. And that was what we called vectorization. That you could apply a function or an operation, across the entire data structure, like a vector. You run it through the vector and to just go, at once. What do you pick up?
And you also see that vector can be as example like T is for truth and X.
Yes. Yes.
And you can also use vector to add, like for example, when you do add a particular number, like 1 plus 1, give you the answer. That's all.
Okay, fine. Yes. You can do additions. You can do arithmetic, addition, subtraction, multiplication of numbers, and then yes. So that is that is part of what we discussed. But I want to just say something about vectors. That's something that is very very fundamental that makes them vectors, and the fact that, like I said, that vectors are always found in a chain. They always go in one dimension. They're always found in one dimension. The things we're going to talk about today, they happen in more than one dimension. That is the key difference between what we're going to talk about today, matrices and data frames. Now, before we start, make sure that you are in a desirable working directory. Just go to your R session. Make sure that you are in the right working directory, and then clear your workspace. We don't want any objects to be in your workspace at this point in time. If you are working on anything, just save it. If you are working on the script, just save it. Yeah, about the exercise that we did last time, what I left you with. How did that go? You are getting error. Okay. Let's quickly. Okay, let's just very quickly, look at it. Let's just look at it very quickly. Sorry. Okay, the file is called create vector, right? This is the script. Okay. I want to run through it by clicking on this. Is that what you did? You were clicking on this button, or how are you running it? What method did you use to run? You were typing it. No, that wasn't necessary. I asked you to just run through it. I didn't want you to type anything, to alter anything in the script. It's there. If it's RStudio, it's there. If it's RStudio, it's there. And also, you can also use if you hold Control, the Control key, and you hit Enter, it will do the same thing. It will run line by line. All right. So.
And now that if I want to run again, I need to clear the ones that are showing error.
You can continue you can just continue. You don't need to clear anything. As long as you didn't tamper with the script.
I said run is Control.
You can say Control Enter. You can hold Control and hit Enter. It will do the same thing. It will run line by line. Okay.
I do I need internet?
No, you don't need any internet to run it. I've cleared my console. I'm going to increase the size so that it is very clear. This my console now is just blank. I want to run them one by one, and I want us to do it together. Yes.
Why running it? Not your console the way particular one you want to run. Or does it
For this, when you want to run a line, you move your cursor to that line,
end of
the beginning or the end, anywhere, even in the middle of the line, doesn't matter. The cursor,
I just noticed this one ran on my console.
yes. So in RStudio, usually, depending on how it is configured, if I run this line, it will jump to the 5th line because the other lines are only comments. So it won't bother with those ones. It will go straight to the actual code. Okay. So if I hit run now, it has run up to line 5, and it's waiting at line 6 for the next command. When I hit line 6, it runs what is in the variable. This variable has a string inside it, and the string reads use type of to check what type of vector this is. That is the content. If you look at the line 5 of the script, that was what we put into it. We see line 5 of the script. That thing that is enclosed in quotation marks is what we have assigned to that name called PRAC. Is that understood?
I don't have this. Creative, but I don't have it.
You don't have what? The file.
Yes.
You didn't get the email. You didn't get the email. I don't need to spoon feed you guys now. I sent it to you by email. So bring your flash. Let me give it to you if you don't have it. Okay. So line 7. I will now run line 7. I can proceed, right?
So I was saying I didn't understand. You explained something that the 5th line was actually what.
Yes, in line 5, what is happening in line 5 is we are creating an object. We are creating a variable, which we have called PRAC. And what we are putting there is a string. And that string is a sentence or part of a sentence. That says use type of to check what type of vector this is. Use type of to check what type of vector this is. Excuse me, let me just give this guy this thing. Is that one clear? Do you understand what happened there now? Anything else that is not clear, just say so. Don't be afraid to speak up. Once it's not clear, just tell me.
Now we moved the resource
I didn't move it, it moved by itself. When I said run, it goes on its own to the next line, like that. Once you say run, it will run that line and move to the next line automatically. Now, I ran line 5, ran line 6. You can see it in the console here. When you run it in the script, it reports in the console. I'll continue. We were on which line? Line 7. Okay. So I'll run line 7. And we are running a function called type of. So this type of is a function that helps you to know what is the type of. Remember I told you that all vectors have a type. So this is now running on that vector to determine what is the type, and it has told us that it's character. We want to see the structure. There's a function called str to give us some insight into how that object is structured. So we have here the results. We have this is character, and it has given us the contents. Okay. Now you run the next line. Just be looking at the console to get the results. The next line, we have now assigned something else to it. Another string that says use length to check how many elements are in the vector. Now I want you to observe something. There's something to learn from this string. Because I'm trying to achieve something here. I've run line 11 now. Okay. If you look at this output, the last word here, PRC, is quoted. Can you see it? It is quoted. Here I use single quotes. The outer string I use double quotes. Can you see that? Now what we are doing here is that because every string has to be quoted, at times you may have inside the string you may have need to use quotes even inside that string. Do you understand what I mean? So if you use double quotes to encapsulate that string when you are assigning it, and you need to use quotation marks inside it, you should use a different type of quotation mark. So we use double quotes to quote outside, and we use single to quote inside. Is that one clear? Is that one clear, Uche? If I had used a single quote to do it on the outside, the inner one should have double. That way I will not be confused. But if I cover that thing with double quotes, PRAC with double quotes, it will give me an error. There'll be some confusion. You won't know which is which. Okay. We are on line 12 now. So the length of PRAC is what? Is 1. So it's a character vector. It has only one string inside it. It has only one element inside it. Even though there are many characters inside the string, but the vector itself, the element of the vector is that everything inside those quotation marks. Assuming you want to count the characters, there's a different function for that. It's called nchar. If you do nchar, NCHAR, it will give you the number of characters inside it. I can show it to you here in the console. If I say nchar and I put inside it PRAC, 64 characters. 64 characters in the string. Do you understand this one? Okay. Now we go back to our script again. We're running the next line. Line 14 has just run. And we are using the same name. We are assigning something different to it. We now said thank and you. Notice we have thank in quotation marks. Then we have a comma following it. We have you in a quotation mark. And we have everything is combined with the C function, the concatenate function. And this will give us this output, thank and U. With the U also has something with it, U exclamation mark. And this is the line 16 says the length of this vector is 2. So there are 2 strings in this particular vector, thank and U exclamation mark. Now I'll skip these ones because this is part of what we are going to do in this current lesson. Okay, so I'll skip these ones. When we finish the lesson for today, we can finish the rest. Okay, that how this initial one is clear to you. You have cleared your workspace, have you? Have you cleared your workspace? How did you clear it? No, let's clear the console, not clear the workspace. Type ls. Check whether there's anything in your workspace. ls with open and close parentheses. Is there anything in your workspace? Is there anything in your workspace? There's some things there now. So can you remove them? What is there? Name one, let me hear. Name one, just name one. What is there? X is there. At least Prac should be there now. So remove everything there. Clear everything from that workspace. Do you remember the function to use? RM, yes. But what arguments will you supply to RM to remove everything at once? List equals ls. Open close parentheses. List equals. Also, we'll even give you the suggestion on what to put there. Equals ls, and ls should have the open and close parentheses. ls, just ls. Open and close parentheses. Then you enter. You had an error. Beautiful. I like that. Error is for learning. Yes? So check ls whether there's anything else in the workspace again. What do you see? If you type if you type ls without the open and close parentheses, it will give you the function definition, which is a long list of things. So put the open and close parentheses. That means you didn't clear it. Try it again. RM. Let me check Maureen's error. It's not LS you type now. It's not LS. RM list. Lists. Why using the RGU? I use RGU now. Want to type Mama now? RGU. Console is here. You put it there, console. our studio, watch this. In our studio, you see, my console is, like I told you before, I just moved it here. You know, you can relocate some of these things. There are different places here. There are 4 main windows usually. We have the environment. The environment is where your this thing is showing, your workspace. The objects in your workspace, they show in this window called environment. Then the console has it labeled there, console. And of course your scripts here. Okay? Now if you want to remove, clear everything in the workspace, you type RM, then list, and LS, and you put the open and close parentheses. Now keep your eye on this window, you see what happens. Immediately I run this line, everything here has cleared. Environment is empty. That's for our studio. If you type LS, which to list the items, you should tell the character 0, which means nothing is there. But of course you can see it visually that nothing is there. It says environment is empty. Okay? Must contain. What did you type? What exactly did you type? Open parenthesis, yes. List. No hyphen. List equals. Yes, equals. Don't worry, it just takes getting used to it. List equals. Then you type ls, open and close parentheses. At the end of your function, you'll be seeing 2 parentheses together. Because, yes. So you enter it. Have you done it? Has it worked for you?
After I type the I'll open the brackets.
Have you seen what I typed here? Can you see this thing I typed here? It's highlighted here. Can you see this one? Yes. Can you type it like that? RM, you open parentheses, you type list.
So the
Character 0, yes. So.
I didn't clear any. Okay. You want me to do it?
Yes, it's empty now.
I'm looking back.
Like I said, it takes.
My own environment is something.
Because the way he arranged it, I was looking
Yours is
at
not
this
empty.
side to clear.
No, yours is empty, but you are in the wrong place. See what you did. That's why also I say it's best to work in the console. It's best to work in the console. My console is up there. Okay, let me help you by bringing it down, so you don't get unnecessarily confused. My console is here, down here. Is now this is the default position. Okay, but the reason why I put it here is because when I want to make it large, I can just no. Okay, fine, no problem. Now, what you did now? See what NS did. Somehow he clicked on this thing and opened something here, something like this. That's what you're seeing, huh?
Yes.
Okay, that's why you are not in the workspace. This is not the workspace. This is somewhere else, which I'll tell you about later. This is the workspace, but it's always safer to just walk in the console and do your typing there. You make less mistakes. Once you know what you're doing, you make less mistakes. Okay. So we're all good to go. Are you happy with your working directory? Very important. Are you using the same working directory you have been using all this while? The same folder. Are you in the same folder where you have been? Okay, good. All right. So, like we said before, vectors, particularly atomic vectors, they have one type of data. Lists can contain different types. Okay, that was what we agreed on. Now today, matrices and data frames, they are 2-dimensional analogs of these of these ones we have worked with. And I said respectively because matrices, like atomic vectors, must be of one type. They are two-dimensional, but they must have only one type. While data frames, like lists, can have different types in the same structure. You'll see that as we go. Matrices are two-dimensional, and they have, which means they have rows and they have columns. Like vectors, they have only one type. So you must have an integer matrix, a character matrix, a numeric matrix, logical matrix, just like we have seen with our atomic vectors. It's just the same thing. All right. And when you do type of like we use type of in the exercise, in a matrix, when you use type of to check the type of the matrix, what it will give you is those basic types: character, numeric, logical, and all that. We can build a matrix from scratch using a function called matrix. There's a function called matrix, and we can also use existing structures to create a matrix. Those there are two functions that are very useful in that regard. We have one called rbind, cbind. Rbind is short for row bind, while C is short for column bind. We can also do what we call matrix arithmetic. It's possible in R, but it's not going to be part of what we're going to discuss, because that is for linear algebra, which is more important for advanced statistical learning, machine learning, and all that. We will not go into all that. Do I have any question from you so far? Is this one somehow clear to you? Remember, like I told you, feel free to always type in what you see. If you have time, just type it in and try it out on your own. If you type in this thing, ARGS, args, and matrix, this function, if you remember, will give you the arguments of a particular function. To give you its arguments, its parameters and arguments. You will see here this says function. This is a function. And these are the parameters: data, n row, n call, by row, dim names. What we have here are what we call default arguments. So the default argument for this data is NA. Default argument for n row is 1. Default argument for n call is 1. Default argument for by row is false. Default argument for dim names is null. What this means is yeah, I've listed all these things, okay? We just said that now. If you look at the documentation by typing question mark matrix, you will see the details of all these things, and every function has those details. Like I told you, if you are creating a package and using function, you must supply all these details. Otherwise, in fact, they won't, the package management system won't even accept it. You must supply all this information. So data is a vector. N row, number of rows in the matrix. N call is the number of columns. Default is 1, 1. By row, it means, do you want to arrange them by rows? When we show you the example, you will understand what this means. dim names, a list of row names and or column names. You don't need to write all this down. You're wasting your time writing it down, because all you need to do is to type question mark matrix, and you get the details of all these things. Is there in your R installation, offline, not even online. Is there. So you don't need to writing all these things down. In fact, these things is more about practice. It's not about writing and cramming the thing. And like I told you way back when we started this thing, I think even the most experienced R programmers, at least I've heard them say so themselves, when they write ups and everything, they always refer to all those things. They always refer to those documentation to do their programming. So it's not about cramming it. Don't bother writing anything, please. Just ask questions. If you have anything, just ask a question. That's what you should do. Don't bother writing anything here. Now, to make a matrix with numbers 1 to 12 that has 3 rows and 4 columns. This is the code we will use. We are assigning to a label called mat. Matrix is the function. The first argument, data. We have supplied a range of numbers 1, 2, 3, 4, up to 12. And then we said we want 3 rows and we want 4 columns. These are the only arguments we have supplied. The other arguments, they will be supplied by default, because we already have default values. And when you run this, okay, I didn't run this particular one, okay? But anyway, if you look at this one, when you look at this one, that was a mistake actually. I don't know why I didn't put the last thing. I should have put in MAT there. But if you look at it on your own, you can do it there on your own. If you write this code and do it on your own. Exactly. That's it. So after writing this code, just type MAT into your session, and then it will now give you the matrix. You will see that it's giving you 1, 2, 3 down the line, right? I'll not do it because of time. Now you can change the dimensions of the matrix. In the first version that we had, we said we want the rows to be 3 and the columns to be 4. Here we are now saying we want the rows to be 4 instead of 3. Okay. Notice that there are 2 things I want you to notice in this line of code I put here. First of all, I enclosed everything in parentheses. Can you see that? What this will do for me, instead of returning that matrix silently, normally it will return like that. The first one I did, it didn't show because I didn't print out MAT on its own. But with this thing around it, it will create the object and also print it at the same time. Secondly, notice that I did not supply the number of columns, but you will observe that it has created the columns appropriately. Because there are 12 elements, I said give me 4 rows. The function has done its own computation to know that 12 divided by 4 should be 3. So the columns ought to be 3. So it has created the 3 columns by itself. Have you seen that? Good. Now, we can change the order in which the values are presented. That by row, the by row parameter. Of course, when you're typing this thing in now, all you need to do is to type the up arrow key to bring up the old code. You just move your cursor to the end of 4, put comma there, and write by row equals true. Now compare these two matrices there. Compare them. What's the difference between the two of them? Look at them carefully. By the way, your values are here. These are your values. You see these ones here. 1, 2, 3, 4, 5, 6, 7. These are the values. These are not part of the values of the matrix. Are you getting me? These are the column and the row markers. Let me just use that word for now. So what is different between these two matrices? The one below and the one on top.
So numbers are just 1, 2, 3, 4, 5.
Yes, exactly.
Number by row.
Thank you, number by row. And that's why we said by row true. So that by row true that we have supplied has changed the way the matrix was created. What I'm trying to show you here, why I'm taking my time to show you this is because it's not only for this function, for so many other R functions that have more than one parameter. Those parameters will determine how the output will be. It will, it gives you options. Options for different versions of your output. Okay. Now to label the dimensions, we now said we supplied this argument here now. Again, look at what I've done with this code. It looks a bit strange. What I've done here is called formatting to make it more readable. Because when you're writing code, you want your code to be readable. Both for yourself, tomorrow when you go back to the code, you don't need to struggle to read it. Or anybody else coming now. This is much more comfortable to read. Each parameter has its own line. Okay? I said matrix 1 to 12, same thing, 4 rows. By row, I said T. I didn't write true again, but it has the same effect. Dim names is the other parameter which we did not use before. All this while we are using the default values, which is null. Remember, it says it's null. But now we are going to supply it some values, and according to the documentation, because that documentation will tell you what each parameter is supposed to carry. This thing I wrote here is something that I got from the documentation. I opened the documentation myself. I read it myself. It's not that I knew it. I had to read it even to prepare this slide. I had to go there and read this in. Even though I've used this function so many times before, but I still have to go back there and check it to know what actually. So I now made it very brief for your own understanding. Dim names says it should be a list. Remember, I told you that to make a list, you must use the function called list. So it says it must be a list with row names and or column names. Now, according to the documentation, it says if you supply a list with only one vector, it will create only row names. If you supply a list with 2 vectors, it will create both row names and column names. That's according to the documentation. Do you get me? So I'm obeying the rules given to me in the documentation to now do this. Now I have 4 rows, so I'm creating a vector for each of the rows. Are you getting me now? And I called this is the list of vectors, and there are 2 vectors. This combine function is what we use to create vectors. Remember? Do you remember? So north, south, east, west. That's the first vector. Second vector, land, water, air. And these are for the 4 rows and the 3 columns. Yes?
That's C for creating vectors. What's the difference between it and concatenation?
That's it. That's the same thing. That C is the concatenate function. This is the one you are using all this while. So anytime you want to combine, anytime you want to create a vector, that has more than that is longer than 1, you must use C to combine the elements to form it. The only exception is when it's a range of numbers that follow sequentially. You can now use colon. You start with the first one and then the last one, and put a colon. It will now give you the range. That's the only. But otherwise, you must use C to combine. If it's like this one now, these are strings. To combine them, I must use C to combine them. The first one is also a vector. This one, but I used a range 1 colon 12, 1 to 12. If I want to use C, I must write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can use C to now create the same thing. But this is shorter than doing that. Are you getting me? Good. So and then this is the same matrix we just had before, but now it has row names and column names. The column name is land, water, air, like we have supplied there, and the row names are north, south, east, west. Okay? And now the matrix now looks, because of what we call, remember I was telling you last time, metadata. It has given this thing some meaning now because we have given it some names around it. The function matrix requires care, especially when you're working with dimensions. Now look at this one that I'm trying to do here now. I was typing and I now made a mistake. Instead of typing 12, I typed 13 for example. And I said n row. 13 is not a multiple of 4. You see, it's not. And look at the output. We have a warning first. Remember I was telling you about warnings the other day. Warning in matrix 1 to 13, n row equals 4. Data length is 13, and it's not a submultiple or a multiple of the number of rows, which is 4. So, but it still gave me a matrix, so. And look at that matrix. This one now has, instead of having 3 columns, this one has 4 columns. It added 13 to the top and used recycling to give me 1, 2, 3. But it gave me warning. In case this thing was done by mistake, take note. Do you get me? But it's still possible to do it. So at times you may want to do it. You may actually want to do it. Just fill up the gaps. But you want to just do your thing. Like, yeah, so you just do it. But to warn you, this is what happened. Okay. Now we can make a matrix using existing vectors, or even other matrices. You can still combine them. And this is what we are going to show here now. We have a vector here called upper. We use letters. You know letters now. You remember letters? Do you remember it? Do you remember letters? Do you remember this? What was this thing? We saw this in the last lesson we did. You've forgotten. Uppercase letters is an inbuilt vector in R. So if you're doing something and you want to use letters, you don't need to start typing ABC. Just use this vector to give it letters. And this one, similarly, is lowercase. But I want to create something called upper. I say upper, and I'm supplying what is here to this upper. Similarly, I'm doing lower. And I said, okay, I want to create a matrix called ABC, ABC. I say matrix function, combine upper and lower. Combine upper and lower. Give me a vector, a long vector with both of them together. And now use that one to create a matrix that has 2 columns. You get me? and I didn't supply any other this thing, argument apart from these two. It has gone there and now done 2 columns of A B C D layouts. Okay, they're so long that the screen can't even show all of them. All right. Or now this is what we use matrix function to do this. Now I mentioned to you cbind. Cbind will combine 2 columns. It will take 2 vectors and make them, it will join them along the lines of columns. And this is what we have done here. The same matrix now, but there's a slight difference between the two. I want to know if you spot it. This one, and this one. They're the same matrix, but there's a slight difference. Ernest, can you see the difference between these 2 matrices? Let me help you out. This one has column names. This one doesn't have column names. This, this function, if you remember, it says column names, the dim names, dimension names, which is for columns and rows. It says it's null by default. So it has nullified, even though this thing has names. This thing has names, because this thing has a name now. Are you getting me? It just ignored it. It moved it because it says no. That is part of the argument by default. So if you don't apply the argument, it will say no. Why this one? I didn't look at the documentation. But some of them they will tell you attributes will be removed, attributes will not be removed. No, now this one, it preserved the attribute of this one, of this name, and use it as a column name. So that's just difference. We have rbind, the same data we're using, but now instead of using cbind, we now use rbind. This is a matrix, but because of the size of the screen, right? It just at 13 it wraps it down to the next line. I get it. You see 14 up to 26. So that is just, if you had a big screen, you just be like it. You just be in one length. Okay. Now, one other thing that is very useful about matrices is not only for displaying numbers or managing such data. For example, when you are doing plotting, which is one of the strong points there are. You can have where you have like different graphs arranged in rows and columns to compare different graphs together. This function is what is used to do it. All right. I don't know if I will ever get to show you that. I don't know if I will ever get there. Not that it's far, but because I think what we're talking about here is not really about. We're not really applying to go into data science, the core of data science, that is statistics and all those kind of things. But if for some reason there's need for it, I'll show you how it's done. Exploring can be done, or exploring a matrix can be done with the following functions. So we have right now in your workspace, you should have a matrix called MAT. I'm sure you have it now. You have a matrix called MAT. LS. Just do LS and check. If you're not sure, check what is LS, open, close parentheses. Do you have MAT in your workspace? You have it there, right? You have MAT. MAT. Type LS. Open and close parentheses. MAT. You have it there, right? No. Just type ls only. ls only. Type ls when you open and close parentheses. Blank, nothing inside it. ls like this. Open and close parentheses. That's all.
Okay, ABC.
You have all those things there. You have MAT there.
Yes,
Good.
lower MAT.
Good. So you can try out all these functions or any of them, not even if not all of them. Just do it quickly. Type view, put MAT inside it. DIM, STR, summary, type of, class, call names, row names, is matrix, edit. Pardon? Yeah, that is if you have it in your workspace. You didn't run any of the this thing we were showing just now. No problem.
In the open and close bracket, are you putting MAT?
Yes, put MAT inside it.
Showing me data, matrix data, row, rows,
Pardon? See what they're showing you now. It's open. See it. See what they're showing you here.
So I click on it, click it from this side.
You click it from that side. Close it. Close it. Close it. And run it from the console. Start from here. Start from here. LS. What is the output in LS? Yeah. No, LS. What do you have? What do you have there?
ABC.
What do you have?
Matrix.
Okay, so you can't even run the example because you don't have anything there. Uche. Huh?
I didn't finish it.
Yeah, she didn't do it. No problem.
The one that was that
It's not a problem. It's not a problem. So, he did view and he saw something. I don't even have it, so I can't run it. Okay. So it's not. As we proceed, we will see more about them. Okay, but these functions, they enable you, like view. What view would do? It will open up a window that looks like a spreadsheet and show you the content of the matrix, just the way you see it in Excel. Dim will return to you the dimensions of the objects. It will start with rows and then columns. STR will show you, like I told you for the structure, it will show you what is, the type and the first few elements of it to just show it to you. Summary will summarize the matrix for you, column by column. If it's maybe like numbers, numeric matrix, it will go by column and give you the sum, the minimum, the maximum, all those things. It just list them for you. Okay. No, we can do all those later. I didn't want to dwell too much on this. Now, data frames. In data management, this is the most commonly used R object, the most commonly used one. You will either get a data frame or you will make your own data frame. All right? They also have columns and rows. Columns are the variables, while the rows are the observations. And like a list, it can have different types. So you can have a column that is made up of numeric elements, and then the next column can be made up of strings. So you can have a column for name, a column for age, like we discussed last time, a column for gender. Okay, and these are different types, but it's in the same structure. You cannot have that in a matrix. It's not possible in a matrix. And indeed, each column of a data frame is actually a vector. Remember I was telling you that the building block of all structures in R are vectors. So that column you are seeing in the data frame is actually a vector. To make a data frame, we have a function called data.frame. And the arguments that we normally supply are vectors that have the same length. For it to work, for that function to work, those vectors must have the same length. Remember, it's rows and columns. So the columns in a table always have the same length. You know that one very well, right? Okay. Now, however, there's a way of making a data frame using using vectors that have different lengths. But it's not this function that you use. You use a different one called expand grid. Expand.grid. That function will create a data frame, but like its name, it will expand the grid. It will just fill up the gaps using recycling and all those things that we discussed to create extra rows to make it rectangular. Okay. For example, look at this code. We have a data frame we have created with the function data frame. We used those two vectors that we did the last time, upper and lower. You can see them there as arguments of that function. And we added a third parameter. We call it position. A vector called position. We're not adding. And we say it's 1 to 26. This we can do off head because we know that if we remember, upper contains 26 elements because we use letters to create it. So they have the same length. They have the same length. And when you look at the resulting output of dim, remember I told that dim is a function that will check the dimensions of the object. It has 26 rows and 3 columns. That's what this thing means here. This dim here, 26 rows and 3 columns. Okay, so each of these vectors made up one column in this data frame called D frame. Is this one clear? I hope this is very clear to you. Because if there's any doubt on this now, please say so. Because I must clear out that doubt, because this is a very crucial thing. Is this one clear to you? Is it clear to you? What's not clear, please? Please never be afraid to speak up once you're not clear. Nobody will think you're stupid. Okay?
And you are saying in the position there is 1 to 13.
1 to 26.
I mean the down.
No, I'm dealing with the upper one for now. That is 1 to 26. That's what position is there. Right? So the result here is that this D frame, which is here, we pass it to DIM. DIM's work is to check that object to know its dimensions. That's the work of this function DIM. Okay, I didn't want to start printing out the whole data frame. I'm trying to show something else. To check what are the dimensions. And there are 26 rows and there are 3 columns. That's what this thing has confirmed for us. Okay? However, this other one, we call this one xp.df. That's what we call this one. We use expand grid to create a data frame. Position here is 1 to 13. They are 13, not 26.
The 3 there, how did you play now?
Which 3?
The 26.
Which one? Is it the first one or the second one?
The first one.
This one.
Yes.
I explained to you that before that the output of dim is a vector with the dimensions of that object. And this object has 2 dimensions. It has rows and it has columns. It has rows and it has columns. And I did say that the first number is always the rows, and the third number is always the columns. The number of rows are 26. The number of columns are 3.
So that's what I'm asking. What made the number of columns you have to play?
Yeah, because
This different line.
yeah, because why there are 3 is because
Position is part of it.
do you want me to print it out for you?
Or is it the
For you to
position,
understand.
the upper and the lower, that is the column, that make it to be 3?
Yes, let me show you. For better understanding, let me show you. Permit me to move this into this side so I can use space. Now we said upper. Upper is what? Letters. Not so. We said lower is what? The other one, the small letters, right? Right? Good. Now we are saying D frame is data dot frame, right? We said position is what? 1 to 26, right?
Yes,
Is there upper
sir.
and lower? Not so. It's run. Okay. Now, if I now run D frame, this is the data frame. It has 3 columns. One is position, 1 to 26. The second one is upper, A to Z, uppercase. The third one is A to Z, lowercase. This is the data frame. Okay. And we said the dimensions, this function dim, will help us to we don't always have to print out everything. Like now, if you're working with it, okay. What of if there are 1 million rows? Will you print out the whole 1 million? But I won't even print it for you. The highest it will be for you is 1,000. But you can know how many by using this function dim. Say dim D frame. It says 26 rows and 3 columns. To know more about dim, you type question mark dim. You can open this page. This is the documentation, and it tells you retrieve or set the dimensions of our object, which is what we have done. Obviously, now. Huh?
Yes, sir.
Great. Now, in this instance, we used expand grid because that's the only way to create a data frame when the vectors are not of the same size. In this instance, okay, let me do it with the data frame. I use 13 here. data frame. Okay, well, it actually worked. It actually worked. Okay. It actually worked. It did its own recycling. You can see it here now. 1 to 13, 1 to 13. Alright? But that wasn't what I was trying to demonstrate. I was trying to demonstrate how it will recycle everything. This one is only recycled along this line here. If I now say expand grid, expdf. See, it stops at 300 something. Okay, and the percent it says omitted 8,455 rows still left that it didn't print, because what it now did is that if you look at what it did now, it used 1, 2, 3 to 13, all the A's, all the B's, just like that. It's just doing something else entirely. Okay. But these are the two ways. Now this one, when you're working with real data, normally we use data frame, data.frame. And when you're doing like simulations, you're also doing some examples. You can now use expand grid to do what you want to do. See, so this one has 8,788 rows. Now, importing data frames. This is a very important aspect, because much of the data, mostly we don't generate data in R. Forget all this I'm showing you now. Assigning as normally what we do with data is we import data from other sources to now work in R. Now, most of the data sets that you import, usually most of them they come in the form of tables, most of them. Now, a useful file format is .csv. .csv, I don't know, have you ever heard of CSV before? Any of you? Do you know what CSV is? CSV is a text file. It's a text file where data is stored, and different data points, let me just use that word, are separated by commas. That's how it looks. I'll show it to you clearly before we go far. So what you see as a column in a CSV file, it will be just a comma. Now we have a key function to read data from such sources. It's called read.table, but it has some variants. We have read CSV, so you can just read the CSV file. The easiest way to start with working with this kind of thing is normally what most of you are used to is Excel. That one is clear. So the easiest way to start, the easiest way is just to save your Excel file as a .csv file. So you have your data in Excel. You can do your thing in Excel. But when you now want to do something else with it, maybe in R, save it as .csv. Now there are many packages that you'll learn about later that will allow you to import data rather from Excel, SPSS. Do you know SPSS? Any of you? Have you heard of SPSS? Yes. So you can actually import the data from those formats using R. Now I will show you how to practically work with this. So when you're doing it on your own, you know what to do. I have here some data that I kept. I got this data from WHO website. It's an Excel file. Now you guys can all these things, I have them together in a folder, which you should be able to collect once you have internet. Yeah, that's why I say I want you guys to please next time bring internet so that we can. I will show you how to access these things on your own very easily. You see this this spreadsheet. This is data from WHO. This is health systems data 2005, country by country, with different areas of interest. Now this is an Excel file, and I'm going to show you how to save this file as a CSV file. It's very simple. Just do save as you normally do. I'm sure you know save as. So I say save as. When you go to save as, say save as type. You now look for CSV. You look for the CSV. This is an Excel file. We are now saving it as CSV. Let me start again. You missed it. You just save as. I'm sure you know save as now. So save as. You now say save as CSV. Save as. There are many options here. You pick the one that says CSV. There are some that are similar. You see CSV here. This one is Macintosh. This one is the MS DOS. We don't want all those ones. It's for Windows. We want it. So this one. So use this one. You now save the file as CSV. Okay, and then you give it some some warning here to keep this format, which leaves out any incompatible features. Say yes. To preserve the features, say no. Okay, because CSV, like I told you, is a text file. It won't all this formatting. It won't ever use it. It's just a text file. So you say yes. Okay, and then I'm going to say I will now close it. Huh? Did you tell her I was here? Did you tell her that I was here? She told her that I was here. My time is very precious, so you guys should know that. Tell her. All right, let me just finish this. Just 10 minutes. I'll be done.
How will you import it?
Yeah, coming. So now I have created this CSV file. Okay. So this is a CSV file that has been. Although I made some changes to the file, I made some changes to make it compatible. That's why I put this slide here. Somebody said I saw this thing on Twitter. Somebody was abusing Excel because Excel is a problem. I'm telling you with data. It's a problem. Okay, but this is the function. If you just type read.csv, and this is just the path to the file. Once you put in the path of the file with this, the file and how you save it as CSV now, that's CSV file. It will now read the data. And when you say dim TBL, it will give us the dimensions of. We now have a data frame called TBL. Are you getting me? It's that simple. Copy what? You get the video now. You get the video.
That one is what we saved the file as from Excel.
I saved it as CSV from Excel.
And that was the name we used to save it. Health
Yes. This is the name I used to save it, and it is in a folder called data, right? So with this information alone, I can import the data into R. So those data are now in this data frame called TBL, and this is the dimensions. It has 192 rows and 18 columns. Very simple. All right. Now indexing and subset. Just just relax. 5 minutes, we'll be done. Now look at this. Look at this code. We're creating a vector called small vec. Now with this thing I've written here, I'll not explain what it means. Later you can ask me. Okay? Since you are rushing off now. But when you run this small vec, this is what is inside this vector. 8, 6, 5, 2, 3, 5, 6, 2, 3, 7. Okay? Now let me ask you a question. What is the first value? 8.
Yes.
What is the last value? 7. What is the smallest value? Clearly 2. What is the largest value? Clearly 8. Which values occur more than one time? 2, right? Even 6 too occurs more. Even 5 occurs. Even 3 occurs twice. Okay? And there are many other questions you could ask about this data. Now, look at this one. Sample. I did something here. I won't explain what this means, but this is what happened. Now, can you answer those same questions with this data? These ones you. Is it possible to ask? In fact, the thing didn't finish. Is even going beyond the slide. There's no way of asking those questions with this data. With this appearance, it's not possible to ask those questions. This is where indexing comes in and subsetting. You can programmatically answer such questions. You get? No, you are that thing. It's not the slide though. It's from the distance. You can't see it. You cannot see it. It's not No, it will come up. It will come up, my brother. So this operator, this is called the bracket operator. We use it to index our structures. For vectors, we use this one. Just single, right? Single bracket. For matrices and data frame, we use brackets but with comma inside it. And for lists, we use both the single and we have one called double brackets. Right? Now for vectors, look at this code here. Letters, single bracket 1. Letters, single bracket 26. Now this is just I'm showing this so you can know some of these things. You can put 2 lines of code in one line. Once you use a semicolon, it will read them as if it's 2 lines. But this is actually 2 lines, but it's just put in one line. I just did it for convenience because I was fighting for space on the slide.
Is it I?
Which in this one?
Yes.
Huh?
Yes.
This is
Okay.
this is semicolon. Right?
Okay.
So letter 1 is what? A. 26 is what? Z.
Z, yes.
So we have used the square bracket to extract the first element in this vector. And the 26th element in this vector is Z. So the square bracket will give you the access to a particular element by its number. Right? Now, 5 letters. We have letters 1 to 5. A, B, C, D, E. Have you seen it? So you can use even a range to extract some of the letters or some of the values in some of the elements of a vector. Look at this one here now. We want to use it now to not to get the value, but now to even set a new value. We want to change the value. So we say 5 let, which is here A, B, C, D, E. 5 let number 3. Index number 3. Assigned to its center. And run it again. We now see that at position 3, we now have something called center there. We have changed the value from C to Centre. Have you seen it?
Excuse me,
Great.
sir.
Careful. See, you have upset our cards. Okay, good. You can even use the C function to pick different elements as you just at random. Yes. So pick number 4, number 9, number 7, D, I, G. You get? It goes straight to that place and picks it just the way you want it. Now, this one, I tried this one now, but it gave me an error. In all honesty, this error happened by mistake. I didn't do it intentionally. But now I want to now ask, do you know how to fix this? How to fix this error? Can you see how? Can you see? Can any of you tell me what to do to fix this error? I made a mistake here. I got this error. It says incorrect number of dimensions. I should have done what?
4, 1, 26.
What should I have done? What should I have done here? Compare, look at here and look at here. Something is missing there. The C, thank you. The C is missing. Right? And it says here incorrect number of dimensions, which brings us to the next line. For matrices and data frames, 2-dimensional, you have the comma. Before the comma, you have row. After it, you have column. So 1, 2 means first row and second column. Are you getting it? That's why here it was interpreting this thing as if it was a 2-dimensional indexing. That's why it gave me this error. While it has only 1 dimension, it's only a vector. Do you get it? That was error that was made here. Now, if you want to get the value of matrix math object, right, on 4th row and 3rd column, you run it like this: 4th row, 3rd column. This is our matrix, our old matrix before. Now, 4th row, 3rd column is what? 12. 1, 2, 3, 4. Column. Sorry, row. 1, 2, 3, 4, and column 1, 2, 3, which is 12. So this is the value 12. And I can change it. I can change that value. Yeah. Yeah. I can change that value. If I assign 1,000 to this string now, row 4, column 3, it says 1,000 here. That it has changed from 12 to 1,000 because I assigned it to that very place. What didn't you understand?
I said if you assign 12.
No. Before the value was 12. What we did here was we checked the value at that position. Row 4, column 3. So if you the intersection between row 4 and column 3 is here. This is the place where they intersect at this very position, and the value there is 12.
Yes.
Right?
Yes, sir.
So and R has told us here that that's the value. He says it's 12. Now what we're doing here is we are changing the value now. We are assigning something to that position. Okay? So if I say
You're assigning now.
I'm assigning
1,000.
yes to that position, row 4 and column 3.
So it's no longer 12.
It's no longer 12, it's now 1,000. That
So
value.
That was what it assigned.
Yes. Okay. If I had made a mistake and not put this thing here, this notation here, if I assign like if you just imagine that that thing is not there, that's bracket notation. Assign this into it will change the whole value of the whole thing. It will no longer be a matrix. It becomes only 1,000. Like I told you one time, what you assign is what you get. What you assign is what you get. anything you assign to the to a name, whatever was there before, it will just discard it. So we had a matrix before. Assuming that you added, you now assigned a word called boy. It changes from matrix to character vector called boy. To forget everything that was for, it just throws it away. Okay, that's the way R works. So what happened? Mm-hmm. We're almost done. Pardon?
At least for us that don't have the background at all. It's easy for us. It's just like magic.
Just like magic. Is it back? I think you need to wait for it. It's back now. Great, thank you. All right, thank you very much. So, like I said before, as we are seeing with vectors, you can also use ranges with two-dimensional indexing, where you have a range of numbers, not just one number. Okay. Now note something here. For these two-dimensional objects, where you have in the brackets, you have the possibility of having a row and a column being indexed. If any of them is left blank, what it means is select everything on that on that particular dimension. So if you leave, for example, here now, we have left the row aspect empty. The comma is there.
To show that something
It's supposed to be there. Thank you. And then we now say 3. What this means is it means all the rows. Okay, I said 5. No, this should be 3. So it means all the rows in column 3. And this is how it will look. This is our very matrix. To just give us that particular row. Now the way this thing appears here, the way it appears here is because the printout makes it look as if it is a row. It's not a row compared to the actual matrix. You see how they are arranged. This is the row now. So we say we wanted this particular row. Is it not? Sorry, this particular column. Column 3. And that's what we are seeing here. 3, 6, 9, 1000. Okay. So what is important here is not the way they are aligned. It's the values. Yes, what we're gunning for. We're gunning for the values. And conversely, if we put the 3 ahead of the comma, it becomes the third row and all the columns. That means the third row, the entire row, every column on that row. So you now have land, water, and air. If you compare it with this our matrix, you can see it here. The third row, 7, 8, 9. 7 is land, 8 is water, and 9 is air. That's just it. Okay. Now for lists. For lists, it can be just slightly more confusing. Okay. Because the single bracket will subset that list. If you have a list of like this one now, we have this list. Okay, we call it sum list. It has 4 elements. The fourth one didn't show here. I should have been more careful with this. Okay, but the fourth one is it didn't show. It's not important. And what we have as the fourth one is the month names, January to December. That's what this vector is here. Now look at this, the way this thing looks. You can see that this is an index with double bracket notation. And this list has vectors in it. So if I type some list, and I say double bracket 1, it will bring out this vector for me. Okay, that's what it will do. But if I use this other one, it will show me this one not as a vector, but it will show me as a list of size 1. That's the only difference. But it will look almost the same thing. Look at it here. I see this one now. This one has single brackets. This one has double brackets, right? The difference between these two, the way they are presented here, this one still has this list pattern. This one we are seeing here shows that this thing is just a list that has one length. List of length 1. Do you get me? It's like, let me give you an analogy that will help you to understand it. A list, assuming that, think of a list as a street with houses houses in a row on the streets, and you have an occupant in each house. Your list is the houses on the row. Now you want to access the occupant of the house. If you use single bracket, it's like knocking on the door. You're still at the door. You have not yet entered into the house to meet with the occupant. So we have a list of houses. You are not at one house, but you are at the house, but you have not yet gained access to the occupant of the house. While the door bracket is when the door has been opened to you. You are now with the occupant. Do you get it now? That's just the way I can describe it to you. So if you now, for example, if you want to work with a vector, for example, in this case, let's say you want to use this value in a computation. That thing is pi, if you remember. That thing is pi. So assuming you want to calculate something using pi. If you use the first one, it won't calculate because that thing is not pi. It's a list of pi. A list is like a house containing pi. So it won't work. But if you now use the second version, it will now work. Right? So when you create like we said before, lists are very useful. You can combine so many, but if you want to now use the list, you want to use the content of that list. To access the content, you must use the right notation to get it. Now, finally, this is where we're going to wrap things up. The $sign operator. This one is used to. This one works only for objects of type list. I didn't tell you that a data frame is a list. I didn't tell you that. Yeah. But it's a unique list in that what makes the data frame unique is that all the vectors have the same length. That's the only thing. They all have the same length. So when you now type that our data frame, say type of D frame, it tells us that it's a list. When you type of, it tells you that it's a list. And when you now type the structure, strd frame, it tells you data frame, tells you how many observations and how many variables you have. And these are the different variables. We have position, we have upper, and we have lower, as we had created before. Look at this $sign here. This $sign is ahead of each of the names of the respective columns. So this dollar sign is what we use to access each of the columns of the data frame. Is that somehow clear to you? Now look at this list. We use the same function on list str. It says list of 4, and we now see the same dollar sign. So if you want to access each of these vectors, you can use dollar sign to get it. Now note this one here. Note the dollar sign in the output. This operator occurs in every list, but can only be used when the object is named. Can you see that there are no names here in this list? Huh? There are no names here. So you will not be able to subset this thing with this dollar sign because there's no name to call it. See how it works practically. To get the column of a data frame, like this, our own data frame, you say the data frame dollar sign position, and it gives us the value here. Data frame dollar sign position. Position is the column. It's one of the columns in that data frame. We have now gotten. You know, you were asking me something last time. You asked me how can we get particular. So this is just one of those things, those ways of doing it. You can now get the particular column. Once you put the name of the data frame, followed by dollar sign, followed by the name of the column you're looking for, to give you the content. The next example, we just picked a different column. D frame dollar sign upper. It's giving us the different elements of that, particular column. Now, note that this subsetted element is always a vector. I remember I told you that a data frame is made up of vectors. If you remember also, when we try to create a data frame, we use vectors, we combine them together. That function called data.frame. We use vectors to make the data frame. So with this, if you want to now access any of the particular columns, you use this subsetting. When we come here next time, I will now show you, because you see the way to really appreciate this is when you see it working practically. Do you get me? Because it's not just subsetting. You want to, because why do you want to now subset? That's the main thing. So when you now see how it works, you say, okay, now it's clear. Because a data frame or a list, there is different data elements that have been combined together to have a certain meaning. All right, but for you to now use it, you need to break it down at certain points of time. Go down to some of the granular elements of that data conglomeration, as it were. You want to now, like if we have a data frame that has age, has sex, has all those things. I mean, you can't just lump everything together and do much with it. You still need to go down to the different details to now get insights. Because what you want with data is insights. It's insight you want to get. When you have your outreach, you put their name, their phone number, their email address, their town, their location, right? That thing is of no use to you as a whole. It's just data occupying somewhere in your computer. But one day comes now, you say, you want to send out bulk SMS. What do you go for? The phone number is not. You go for one column. the column that has the phone numbers. You go for it straight. So you not need a way of extracting it from that table that you have saved. Now we're doing the same thing in R. To now go down and pick out something that we want, or change something that needs to be changed.
This data you mentioned, like, can you create it directly on R
You can.
instead of not using Excel?
You
So
can.
that you don't need to export it.
You can.
Let's say if you have it on Excel,
You can.
now export it
Like
to R.
like I told you, we have put some things together for you guys. First of all, R doesn't store data. We don't store the data in R. You store the data in your file system. That's the normal thing. But what R, but,
Maybe on Excel, but when you want to use it to import.
yeah, even Excel doesn't store data. Excel is a format for how do I put it? Yeah, for working with data. The data itself is stored in your hard drive. Remember I told you that the data is ones and zeros. That's where it is stored. So even for Excel to use the data, it has to go to your hard drive and bring it out. Do you get me? But what you can do with Excel, there's certain things that Excel is very good for, and there are things that R is better for. Excel is not too good for getting insights into data. It's good for maybe like spreadsheets, presenting data, maybe those kind of things. Having good, nice tables, format them very well, make them easy to read, those kind of things. But for now, doing proper data analysis, it may not be too ideal. Conclusion. We have run through the main data structures. This is just an introduction. We have also seen some ways of manipulating them. The key to learning R is actually practice. It's just practice. And practical use cases, they are bound. Really, if you want to pick up, something like R, is in the practical application, in your day-to-day operations. That's where you pick it up. Do you get me? So, what we'll do is, as time goes by, we'll look at some of the practical uses where it's useful. So exactly, that's how you understand it. That's how you learn it. Yes. Otherwise, it just looks like magic, high for looking stuff. But this thing is meant.
But we still need to know the basics. So that you know what
These are the basics.
you are doing.
Yeah, because after having what we have done now is like the basics. When we now go to the practical, and that's why I said you must have internet next time. But when we now go to the next stage, we'll start moving towards those things that were done here using R. We'll open up all those projects and look at how to use. It's not hard at all. But that's when some of these basic things will now start making sense. Okay. All right. Any questions, please? All right. Thank you so much. I appreciate you for Q.